Now, in previous slide, okay, we learned about the change in volume, isn't it? Okay, ataupun the coefficient of volume expansion given by beta. Okay, now for gas, all right, we cannot actually measure, okay, the change in volume of the gas. Okay, it is not that accurate. Right, so in this subtopic, we're going to find out, okay, how, okay, to find the change in volume of the gas. Right, so meaning that we are not going to apply equation delta V equals to beta V naught delta T untuk gas. Alright, it is not practical. Alright, okay, not practical for gas. Alright, for gas. Alright, so how? Now, consider a gas, okay, that is confined in a piston like this, alright? Okay, now, for the gas, okay, to behave like an ideal gas, okay, like an ideal gas, right? We should place the gas at a low pressure, okay, low pressure ataupun low density, right? Low density, so that the molecules, okay, in the gas behave like an ideal gas, alright? Now, if we press, okay, or expand the piston, okay, slowly, alright, then we can remain, okay, the pressure of the gas, right, at a very small value, right? So we change, okay, the volume by, okay, pushing up ataupun pushing down the piston here, alright. Okay, so we push it slowly so that we can maintain, okay, the low pressure of the gas inside it. Right. Now, if, okay, if the low pressure is maintained, then we can say that, okay, the molecules inside obey equation of state. Alright, equation of state. Alright, so the equation of state, or ideal gas law equation, okay, equation of state ataupun ideal gas law equation. Alright, ideal gas law equation. Alright, it is given by, I'm sure that most of you know this equation, PV equals to nRT. Alright, so this equation, okay, relates, okay, give us the relationship between pressure, volume, and temperature of an ideal gas. Alright, of an ideal gas. Okay, now, so what are all the symbols here means? Okay, so we look at N first. N. Alright, so N is the number of mole. Okay, it's known as number of mole. Alright, so how to find the number of mole? Okay, we have two ways to find the number of mole. Okay, one is if we know the mass of the molecules, right? So we can find it from M equals to molar mass, right? Mass divided by molar mass. Okay, okay, molar mass ni must be in kilogram. Okay, must be in kilogram. Okay, in periodic table, alright, the molar mass is given in gram per mole. Okay, meaning if you want to use this equation, you kena convert dulu dalam kilogram per mole. Alright, so it must be in kilogram per mole. Alright, mass must be in kg lah, right? Another way to find the number of mole is by using the concept of number of Avogadro. That is N over Na. Alright, where N is the number of molecules. Bilangan ya, number of molecules ataupun number of particles. Alright, and Na is number of Avogadro equals to 6.023 times 10 to the power of 23 molecules per mole. Alright, so this is the number of Avogadro. Alright, now, so this is how to find number of mole. Okay, as for the pressure, okay, in the ideal gas law equation, okay, pressure must be in unit Pascal, SI unit. Okay, and you need to know that, okay, 1 atm. Now, some questions, okay, they give us pressure dalam unit atm. Okay, atmospheric, atmosphera, right? So 1 atm convert to Pascal, it will be 1.023 times 10 to the power of 5 Pascal. Alright. Now, as for the volume, must be in unit meter cubic. Alright. And some question, dia bagi dalam unit liter. Alright. So, you must know that, okay, 1 liter equals to 0.001 meter cubic. Alright. So, kalau you minum air 1 liter, it will be equal to 0.001 meter cubic. Alright. Okay, next we have volume and then T. Okay, T is temperature. Okay, must be unit in unit Kelvin. Okay, kalau dia bagi dalam Celsius, you need to change to Kelvin. Alright, and what is R? Okay, R is universal gas constant. It is given by 8.314. Okay, 8.314 joule per mole Kelvin. Alright, per mole Kelvin. Right. Now, okay, in ideal gas law equation, right? Sometimes, okay, we may have, okay, one parameter is kept constant, right? So we look by cases. Now, if T is kept constant, okay, if T is kept constant, right? So what happened to this equation? Right? So kalau T constant, so meaning that the right side of the equation ni remain constant. And constant, R constant, T pun constant. Alright, so kalau T constant, it means that PV is constant. Alright, PV is constant. So we have that P1 V1 equals to P2 V2. Ataupun kita boleh kata P is inversely proportional with the volume. Alright, so this is basically Boyle's law. Alright, ini adalah Boyle's law. So you can refer at page 492, okay, in your textbook, right? So this is Boyle's law. Alright. Now, next, if P is constant, okay, if P is kept constant, alright, P is kept constant, so what happened? So the ideal gas law we will have kalau P constant, okay, so meaning that kita ada P is kept constant, so we have P over and R is constant. Alright, meaning I rearrange the equation here. P over N R is constant. So therefore I have, okay, ni sama dengan T over V. Alright. So kita ada T over V ataupun V over T lah. Okay, pun boleh. Alright, V over T is constant. Alright. So here we have V 1 over T1. Okay, equals to V2 over T2. Alright, ini kalau P is kept constant ataupun kita kata V is directly proportional with the temperature. Alright, so in this case, okay, this law is known as Charles' law. Okay, Charles' law where volume is directly proportional to the temperature. Alright, so ini adalah Charles' law. Alright, okay, next the other one, okay, if okay, wait. Alright. So if volume is kept constant, alright, if V is kept constant, what happened to the ideal gas law equation? Alright. So kalau V is kept constant, alright. So here we will get, okay, P dengan T is directly proportional, isn't it? Kalau V constant, P dengan T is directly proportional. Or we have P1 over T1 equals to P2 over T2. Alright, so this is Gay-Lussac law. Alright, Gay-Lussac law. Alright, okay. But we do have situations where PV dengan T dia tak berubah. Ada juga case where we have PV and T they change, okay, at one time. Right, so ini adalah general cases. Alright, so in the next slide, we are going to find out some examples, okay, regarding ideal gas law equation.